Okay, hi everyone. Let's talk about GraphQL on the ASP.NET Core platform, and we will cover quite a few topics tonight. Okay, this talk contains a lot of live demos. Expect things to explode, and I hope you enjoy it. So let's get started. So GraphQL on the .NET platform was until recently not really existent. There were some libraries available, but they had a lot of shortcomings compared to the JavaScript community. So let's talk about what GraphQL is first, before we get into how we can do it on the .NET platform. So when I go to meetups or conferences and talk to .NET developers about GraphQL, the first reaction we get is, what the fuck is GraphQL? And this is mostly because there is not a great API support, or there was not a great API support until recently. So what is GraphQL in short? GraphQL is a query language for your APIs and a query engine to execute those queries. And GraphQL was developed by Facebook in order to fix their needs to fetch data more efficiently for their mobile apps. Who did remember the first Facebook apps here for mobile devices? Nobody? They were kind of crappy, very slow, and people hated them, and they thought Facebook will vanish from the earth because they were so bad. And that's basically when Facebook started inventing GraphQL. There were three guys at Facebook. One of them was Lee Byron, and they came up with that. So GraphQL was then open sourced by Facebook in 2015 as a specification document, which was picked up very quickly by the community. And nowadays it's used by companies like Netflix, Twitter, even the New York Times, and many, many more. So the biggest internet companies today run on GraphQL. So it's very battle tested and super efficient. So before we go into it, I'm Michael Staib. I'm one of the co-founders of Chili Cream, and we are heavily invested to make GraphQL better on the .NET platform. So who is this talk for? This talk is, that's what we do with user groups usually. We have the introduction, so it's for everyone who wants to get started with GraphQL, but we will drill down into GraphQL, look at things like how we can scale GraphQL and stuff like that. So it also will be very valuable to people that know GraphQL already. So who here actually knows GraphQL at all? Anybody? Okay. Who has used it really in projects? Okay, two. Okay, so that's good, because you all will learn something new today. So let's start it with a demo, because I like presentations with a lot of code. And I have prepared a little exercise here. So let's I hope everybody knows Star Wars, because otherwise you will get lost in the example. So I have a simple example, a simple demo here. We want to fetch all the characters that appeared in movies together with Luke Skywalker. So just a list of names. It sounds quite easy. So let's first have a look how we would do that with REST. So there is an API that's called the Star Wars API. It's hosted at swappy.co. I hope everybody knows it. It's an exemplary REST API, and it's frequently used to teach people clean REST APIs. And REST is very easy to us .NET developers or backend developers in general, because it basically drives the web today. And if we look at such a query documentation, we know how to use it. We see it has a few resources which are exposed here through endpoints. So I have a people's endpoint here, a planet's endpoint, a film's endpoint, and so on. I can drill into those endpoints by fetching them. Like I could fetch the people's endpoint, and as I expect, I would get a list of people here, which basically are the characters in the movie, like Luke Skywalker, 3CPO, and so on. And I can even drill in further. Like, I could append the ID of a specific character to my endpoint, and then basically get that specific object. In this case, Luke Skywalker. And if I look at that JSON object here, it's easy to read. It has a name, height, mass, and stuff like that. So it's very easy to explore that API. And if I look further at the API, I have array films here. And this films array consists of URIs. And these URIs are actually references to other endpoints. And I could drill into that and fetch one of those references and get the films object. Again, easy to explore. And I can see there's a characters array, again, represented by references. And I could drill in further. And it's easy to see how we could get our data here. So I have gathered all my JavaScript knowledge and wrote a little program here that basically now fetches the data for us. So the algorithm that we would have to write to fetch the data from our REST API is quite easy. We would first fetch our Luke Skywalker object. That's here. Then we would iterate over the movies. Then we would fetch each of the movies. We would iterate over the characters. And then fetch each character. At the end, we would do a little data massaging. That's basically I'm pushing the character object to an array here. And then we extract just the name from it. So by just looking at it, I can already sense that it's not very efficient or very performant because I'm fetching a lot of data that I do not need. So let's have a look at my little program. I hope internet connection is all right. Let's refresh it and see how that performs. So I push the red button here. And you can see that there are a lot of connections and a lot of data pulling is already happening. So we did 124 requests just to fetch basically a simple list of names. And if you look at popular websites, I would have said Medium, but they migrated to GraphQL. But before they migrated to GraphQL and you headed over to Medium to just read your blog, you had more than 100 connections just to fetch the data from the backend. So that for what it didn't perform that bad. It's just 6 seconds. And we fetched a lot of data that we didn't need. So let's have a look at how we would do that with GraphQL. So for that, I open up a tool that is called Playground. So Playground is a tool to explore GraphQL APIs. It's based on GraphQL, which originally was developed by Facebook. And on the left-hand side of Playground, I can write queries. On the right-hand side, I will get my response once I fire the query up against a GraphQL backend. And I have here 2 buttons. One is Docs, and Docs lets me explore my API. I can see my API has a field characters here. And if I click on that, I can see my characters field will return a type that is called characters. And I can see it has similar data like my REST API. I, for instance, have a name field here, I have a height, and I have a movies array. And the movies array is not made up of references, but actually returns me movie objects. And I can see that my movie object then again returns a characters array here. And I can drill in here. So before I did my first request against my endpoint, I could already explore my API quite thoroughly. So let's see how we would write a query. So a query starts basically with a keyword query. And then I write the query somehow like a JSON structure. But it is actually not a JSON structure. So I'm writing here my squiggles, and then the tool already helps me along by suggesting, okay, there's a characters field. and the characters I field needs an ID. And I can type in the ID 1 because I know Luke Skywalker has the ID 1. And as I go along, it suggests me things that I can use. So basically I have IntelliSense. And let's just fetch this character with a name. Okay, that's interesting. I'm not getting a full object like I got with REST. I just got what I specified in my query. So I specified I want a character here, and I want the name of my character. And I got exactly that. So it looks like I sent an empty JSON graph into my server and get a filled JSON graph out of it. It is not like that, but it's a good mental picture to start with how GraphQL works. Okay, so let's explore the API further. So I can write here movies, and then I can drill in, like I can fetch the titles of my movies, for instance, or I can fetch the characters that played in that movie or appeared in that movie. And then let's fetch that. Okay, boom, I have my data here. And I get the data like I want them to be shaped. Okay, so let's do what we actually wanted to do. We don't need that name, and we don't need that title. What we actually wanted is just a list of the names of characters that appeared alongside Luke Skywalker. Let's fire that up, and I'm basically done. I have defined for my server the query, which basically describes which data I want, and the server gathers all the data as efficiently as possible and returns the data to me. So let's see how that stacks up with our unscientific benchmark here. So let's refresh that and see how fast GraphQL can do that. 250 milliseconds. That's good, but if we look closer at this, it actually took only 45 milliseconds because the other request here is the options request for our course middleware. So actually, our data call just took 45 milliseconds. That is, I don't know how much faster, but a lot faster. So 6 seconds with REST, 45 milliseconds with GraphQL. And the trick here is actually the GraphQL API that I wrote there is just a wrapper around the swappy.co. So actually the GraphQL API fetches the data from the original REST API. So why is it so much faster? Because both APIs are hosted in the cloud and I have unlimited bandwidth there. To run like a data fetching algorithm on my client is actually very inefficient. But running it in the cloud is much faster. So just by putting a GraphQL wrapper over your REST API already makes it much faster to consume. Let's reflect on what we have just learned. So in GraphQL, the query and the response closely align. And that puts the consumer of your endpoint or the consumer of your API in the driver's seat. You as a consumer of a GraphQL API define what data you want, and the server just fulfills your data need. And that allows you to iterate much faster. Because in a traditional sense, when a front-end developer needs some more data or needs some more of this or needs some less of that, he has to always ask the back-end developer to change the API. With GraphQL, you don't need to do that anymore. The back-end developer just defines the type system and the schema, and by that basically defines all the data that is available, and the consumer defines how he wants to consume the data. Okay, so with REST, it's more, we are exploring the API, we are looking at the results, we are fetching some data, and we have a look how the API works. Sometimes that works out, and sometimes it's not, because with REST we don't have a guarantee. There's no type system, and even with Swagger, the types are metadata. They are not really, they are not enforced by a query engine. They are not enforced by a type system. It's not like you're writing a C# type, and it's guaranteed to be like that. With Swagger, it's just I tell you that it looks like that, but it doesn't have to be like that. Okay, so we can also do dynamic endpoints with Swagger, but if you go down the route of dynamic REST APIs, you end up like this Amazon Shop API with a lot of parameters, and the API becomes unreadable. And also, we don't really know what all the types are there. Is associate tag, for instance, an int, a long? Or can I even feed strings in there? I don't know. Okay, what is GraphQL? So GraphQL has only one endpoint. That's opposed to REST, where you have multiple endpoints. And with GraphQL, I can fetch all my data that I need in one request. And that's crucial because we want to have efficient web apps, efficient mobile apps. And with GraphQL, there's no over or under fetching. Overfetching is actually when you looked at our first algorithm, I had to fetch all those data that I didn't need. That's overfetching. And underfetching is if you remember the request and we had those URIs there, these references to other resources. That is underfetching because I actually wanted this reference. I didn't want it just the URI. So you don't have that with GraphQL. And GraphQL is enforced by a type system. So it's built upon a type system, and we will see more about that in the next demo. And by just providing types and building upon your type system, your schema, you produce already a lot of documentation. When we explored our API at the beginning, we just looked at the type information. And that's a lot of documentation that comes for free, if you think about it. And in GraphQL, there's no versioning concept. So in GraphQL API, it's more aligned like with C#. You would deprecate fields, like you put an obsolete tag on a property. So it's more in line how we developers already develop our C# programs. And GraphQL is real-time, and we will have a look at that. And all of this makes GraphQL very predictable to use, and it's super simple. Okay, let's have a demo how it actually works in C#. So I've prepared a little thing here. So let's start with a simple hello world, just to warm us up. So we say code. Okay. So this is a standard GraphQL. Oh, super, it's downloading my new OmniSharp package. So we have to skip IntelliSense for a second. But okay. So this is a standard ASP.NET Core project here. It has nothing special in here, except it has the hot chocolate ASP.NET Core package in there. And also the startup is just an empty startup. Every GraphQL server starts with its schema. And the schema is made up of several types. And every schema has to have root types. And the most important root type is the query. So let's first create a class called query. So we just type up a class here, query. Let's say it is a string. It's called hello. And we return word. That's simple enough. Okay, and now we have to have a schema. So we have here some dependency injection extensions at GraphQL. And we have something that's called the schema builder. It's still downloading. Oh, should. Okay. So we can say schema builder new, and the schema builder basically helps up building that complex schema type. So we can just say here add query type, and then, we say query, and then we say create, and we are done. Basically, that's the simplest way to create a schema in GraphQL for .NET. So let's now, okay. See a typo here. So, okay, finally my IntelliSense arrived. Okay. So now we need something to execute on that schema. And to execute on that schema, we need a middleware. So we say use GraphQL here. Okay, let's run that. .NET watch run. Oh, sorry. Yeah. And we'll swap the tools for a second. So this is also a UI that's basically developed by our open source project to explore GraphQL APIs. I should have closed these earlier. Okay. Okay, let's start with our hello world. Let's fetch our endpoint. And then look at our schema. I can already see I have a query type here. I have a hello field here. And that means I should be able just to fetch that hello field. Let's do that. Boom, we get our data. So basically, it's very easy to get started. We just can provide some simple types like we are used to do. I do not have to write anything special, and I already come up with the schema. But actually, the schema is not fully specified. There are more things that I could add to that schema in GraphQL. GraphQL, for instance, has this concept of non-nullability. C# now has it too, but in C# it's like with Swagger, it's just metadata. And we are integrating that metadata automatically with the next version. But for now, let's specify something called a schema type. So we come up here with a query type, and it's actually an object type, and it's an object type of query. And this type actually allows me now to specify more GraphQL properties of my actual root type here. So I say protected override void configure, and I get something here like that's called a type descriptor. And that basically lets me add more information about a certain field. Like I could say, okay, my hello field here, my field hello actually is a non-null string type. Let's say that. Okay. And instead of providing my type here now, my root type, I'm adding here my query type, my new schema type. And if we run that in our tool, we will see that we now have here an exclamation mark. And that means this type is a non-null type. Execution-wise, nothing would have changed. So I can execute it, I still get hello. But if I now try to violate that contract, like putting in here null, the execution engine will actually now protect the consumer from getting invalid data. So I can refresh that. Okay, we are back. So I now get an error here that says, okay, the server actually is in an invalid state. I won't give you that property. And the interesting aspect is that if the server violates the contract, then you will get, if you have larger queries, get partial results back. So GraphQL is not like REST where we would fail everything when something unexpected happens in the request. So GraphQL can also return partial results. So that was it for Hello World. We've done our first .NET GraphQL server. So let's get deeper into it. So GraphQL exposes its data through operations. We have the query operation, and queries in GraphQL are side effects-free reads on the server state. And this is important because GraphQL executes each resolver in parallel, and that makes it super fast in fetching the data from your backends. And then there is a write operation. You could compare that to put, post, patch, delete. So in GraphQL, it's just a mutation. It doesn't matter. So the complexity of thinking about what kind of mutation you have to write is gone. So you just write a mutation and it changes the server state. And mutations are not executed in parallel but serially in order to have a predictable result. And then there's something called events, subscription, which is basically events, so real-time data. And I think we should have a look at that.
Michael, when you say about events, the actions happening in serial or parallel, is that on the client that's happening?
No, that's backend execution algorithms. So basically, the query engine executes I'll show that in a sec. So let's start another Star Wars server here. .NET Run, project, Star Wars. Start with the mutation. I have prepared another Star Wars example here, which allows us to write reviews for our movies. A mutation in GraphQL, just let me fetch that. Okay, a mutation in GraphQL starts with the keyword mutation. And just as a thing here, because I before, in the last example, I just did the squiggles. By default, queries are expected to be a query. So if you don't provide this keyword, what operation you are doing, it's actually always a query, just as a hint. So by providing here the keyword mutation, I'm telling the GraphQL server that I want to change something on the server. And now I only get the mutation fields. In this instance, I get here a review. And I can write a review here, for instance, for New Hope. And not episode, the review. And I can provide a commentary here, like this is maybe something. This is a good movie, for instance, movie. And I can give it some stars, maybe 5. And then I can select another fields, and I will explain that now. Right. So if we look at the query structure now, the top part, just this part is actually the mutation. So this is what changes things on the server. And this down here is already selecting data. So I'm querying already the changed data. And this is very interesting because it allows me, like if I have more complex changes, like I'm linking objects to different objects, I can reselect query on the changed server state and reselect that data. And that's very powerful. But what does executing mutations serially mean? It means that I could say, this is my mutation A, and this is my mutation B. And the server would now start with A, and then do B. And only after B is executed, we would do the querying on this we would do the queries. So first this would be executed, and then this would be executed. And with the query algorithm, we would execute everything in parallel. So going down the graph with the depth first algorithm, but in parallel, like each field would be its own root field, and we would drill down in parallel, which is very efficient for querying data. Okay, let's get rid of that. Okay, that is, in this example, it's not very spectacular because we just reselected what we have written into the server. So I did a mutation that basically created a review here. This is a good movie, and we reselected this state. But it is really powerful when you do it with large examples. Okay, let's look into subscriptions, and they are kind of related to mutations. That's why we are skipping to subscription. So subscriptions basically allow me to ask the server for data when something changes on the data. So I can say, okay, when a review for Empire Strikes Back appears on the server, I want to fetch the stars. And I can fire that up, and actually nothing will happen, because I just tell the server, execute that query when a new review arrives on the server. And I might have just written an analytics program that aggregates the stars here. So I just want the stars. And if I execute now this query that is on New Hope, actually nothing happens here, because I said I only want to be notified and get the data when something is written for Empire Strikes Back. So that means if I do Empire Strikes Back here, maybe give it 3 stars, fire that up, the data is already here. And this scales quite good. It's done over WebSockets, but we are also working to do that over SignalR. So when you have older browsers, that we also support that. And this not only works with such small queries, you could have large queries and get the data only when you really need it. So you're not anymore pushing and pulling data. You're not anymore pulling data. You're basically getting the data pushed once something changes on your server. Okay, it's also important to look at what GraphQL is not. And if people look at GraphQL, at the name, they sometimes think it's a graph database query language, or it's Google's query language. But it is not. It has nothing to do with Google. It doesn't have anything to do with GraphQL, with graph databases. And GraphQL is not a good solution for binary streams. So if you are Netflix, you wouldn't use it for streaming movies. Netflix actually uses GraphQL, but not for the streams. And it's not Facebook's version of OData. And if you drill into GraphQL, you see that it's quite different. OData was designed for is an abstraction over your basically data source, database, and it has a complete different mental set. Like in OData, you have things like primary keys and entities, and GraphQL doesn't dictate these things. GraphQL is a layer over your API, and that means it has terms that you define. So it's your ubiquitous language that is exposed to a GraphQL server, not like with OData, which is driven by database semantics. And GraphQL is not bound to a specific data source, and we will see that later in the talk, what we can actually pull together with GraphQL. It's not limited to HTTP, and we actually, at the moment, with the upcoming version of our GraphQL server, we are supporting not only WebSockets, which is already in our current version, but gRPC, SignalR, and other protocols. So GraphQL is transport agnostic, and the GraphQL spec doesn't dictate any transport. So actually, at the moment, we started at the work group to specify how GraphQL should be served over HTTP. Until now, there was no specification for it. And GraphQL is not limited to JavaScript. And if you think about what I said in the beginning, Facebook built this thing for mobile applications, for native mobile applications. So it started with basically apps that were written in C++ to consume data in an efficient way. It just exploded in the JavaScript space. So every JavaScript developer knows GraphQL, and most of them love it. It's also important, and we will have more time in this talk, so we will talk about also the challenges. First challenge in GraphQL, it's called the n+1 problem. And it's about fetching data in a graph. If you think about deep graphs, then fetching data in a consistent way is one of the challenges that you have to deal with in GraphQL. And also scaling a GraphQL server is more challenging, like with REST. With REST, you have thousands of endpoints. You can basically easily put up multiple of them, and you don't think about that. With GraphQL, you have one endpoint, and so it's more challenging to scale that. So we have a look at how we do microservices with that later. And estimating the performance impact of queries on a GraphQL server is also more challenging. Because if you think about REST, it's quite easy. you could take each of your REST requests and easily estimate how much performance impact a REST request has on your system. With GraphQL, it's more dynamic, so it's more difficult. And also doing something like rate limits is one challenging point in GraphQL. So let's start with the first thing here, fetching data. So I have prepared a little example. Let's say we are building the next Twitter, and we have a query that fetches a message stream. And the message stream, basically, each message exposes its creator, but it also exposes the message to which it was a reply to. And the reply to is again a message, so I can also fetch the username here. So if you think about executing this graph from top to bottom with a depth first algorithm, you would first fetch the message, maybe, then fetch the user for this message, then drill in, fetch the reply to here, and then fetch again a user here. So we have two problems here. The first thing is we have to do two fetches to the database to fetch users. Because when we fetch this message, we might not even know if this message even exists, so how can we fetch the user here? The second thing is, what if the user is the same and changes while we are executing our query? So basically the user could be named here foo, and now it's called bar. But fear not, Facebook defined something they called initially preparables, which they specified now as data loader. And data loader are basically like an interceptor between your resolver, and the resolver is basically what fetches the data for your field, and the data source. And the data loader does two things. First, it caches. So within a request, within one request, it caches the entities that it has resolved already. So if we hit one time a user and resolve that user from the database, we will not fetch it a second time. So we have data consistency here. And the second thing is the query engine combined with the data loader will aggregate all calls to a certain entity and batch it. So we end up with a lot less database calls to our, a lot less calls to our data source. Okay, let's have a look at how we would do such a thing. It sounds complex, but it is really not. Okay, this is the fourth demo. Okay, so this is basically the example I showed you here. And I have a message type here. And the message type is implemented naively. So basically we have our created by field here that fetches from the database through its repository the user. In order to fix that implementation, we have to add here a data loader. So let's copy and paste that because I don't want to waste precious time. So we put that here, and then I'll explain it. So we still would use our user repository because I don't want to throw away that nice API. So the thing that I do here is I ask my resolver context to use a batch data loader, basically batch the requests to my database. And I tell the engine that this data loader is called user by ID, and it should use my user repository to actually fetch the data. And because it's a batch data loader, I specified here a batching function to my database, which actually receives a collection of IDs. But then the actual resolver will only fetch the data through that data loader and ask for one ID. And the execution engine will basically aggregate all those requests. And then when all the resolvers that ask for that data loader are enqueued, it will batch all the requests in one go to the database and fetch this graph data very efficiently from your database. So let's run that Let's do a watch run. When that comes up, go here. Okay, let's refresh. This should already come. Yeah. Okay, we can easily drill into our data. I ask for messages here. And I can fetch the created by here, fetch my name, and fetch the text here. Okay, from the execution side is actually, oh, sorry. It uses an actual database, and I haven't started it. Sorry, that is too small. So let's do that here. Docker start Mongo. Okay. Let's do that again. And we get our data. So while this is not spectacular, let's drill more into data fetching in GraphQL. So actually, if we look at our request again, it looks kind of dangerous because I'm fetching all the messages here. And this would, with Twitter, pretty much kill my server and kill my client, maybe. So what I actually want to do here is also data paging. And Facebook introduced something that is called cursor-based paging. And that's very interesting because it allows you to really slice your data. So how do we do paging with GraphQL? With Hot Chocolate, we have a concept that is not only resolvers, but also middlewares, field middlewares. That means instead of using the resolver here, I can also build up a pipeline and say, OK, I want to use paging. And my entity type is actually message type. I don't need that anymore. And now the resolver returns a queryable in this instance. And our paging middleware will generate paging calls to my database and fetch the data in a way that is very efficient. And I don't have to rewrite my extra repositories. So when we refresh now, our data, my tool will already tell me that this is not right here because my data has changed. So let's explore that. First of all, I have a lot of arguments here. So I have an argument that is called first. So I can say, give me the first 10. And this doesn't sound very innovative. It sounds like the skip and take approach, but wait a second. And then I have something that is called edges. And I have an edge represents a cursor. And the cursor defines my position in my data set. And it defines my position in my data set in a specific data set. So if I had sorting and stuff like that on it, it defines my set in that data set. And actually, if you implement it right, it also prevents you from those jumping paging, where you add data while you page through it and your paging really jumps. You don't see that when you are working with Facebook. When you scroll through the Facebook stream, it's very smoothly. And that's because of these cursors, because new data will be added to the top of the data set, and that prevents you from jumping, from getting jumps. We'll have a look at that. So the second thing here is something that's called a node, and the node is actually my message now. So I can put that in here, reformat it, execute it, and I now have paging with just one line of code. And I have this cursor here, which is base 64 string that describes exactly where my item is located in my data set. And now comes the tricky part, because I can say now first, I want the first, let's say the first 2, and I want the first 2 after my cursor. Okay, well this is nice. I get the next, I should get the next. First 2 after my client. Should have. Is it the same? It's a different, huh? Yeah, okay, so sorry, it's sometimes different. You have to spot the difference. Okay, so I can now get the first two after that, but I could also say, give me the last two after that, or give me the last two before that. And I can even combine that and slice my data from both sides. That means I can really slice for the first time my data however I want. So I could get the first 10 from the last item in my data set without thinking about, okay, I have to do a full count on my database, which is very expensive, and then calculate back. So in this case, I just fetch the last cursor of my data set, and we have something that is called here just a page info, and I could ask for the last cursor. So I could ask very inexpensively my database to just fetch the last data set, get the cursor from that, and page backwards. Okay, but that's not enough. We might want to have something that is filtering. I want maybe to filter my data.
Okay. So is that using server-side state there or not?
No.
Oh, cool.
Query and mutations are stateless, whereas subscriptions are stateful because they have an open socket connection. So I want to do filtering on my database. I want to filter over the messages and stuff like that. So I can, again, it's a pipeline here. I could say, oh, I can see I forgot something in my demo. There is another package that you could add, and that's called types.filters. Yes, restore that. Restore it. Go back here. Okay, and now we have something that's called use filtering. Let's save that. Go back in our tool. Refetch our schema. And now I could say, okay, I want the, let's put the cursor away because that changes now. But we want the first two, let's say the first two, where the text contains, and you see all those operators that I have now here. I can ask where the text contains, where the text ends with. I have all those operations now with just one line of code. And it translates the GraphQL query directly into your database query system. So we're using Queryable to build expression trees. And these expression trees are translated then to Oracle or SQL Server or Mongo or whatever you have. So we could say in a simple contains here on the text, for instance, and look for B. So the first B, the first two B's we want to find. So bar and buts. Okay, but we could even say, okay, and let's do another query object here. And actually, we want to have the text ends with Z. Okay, and now we just got one item. So I have a very powerful query filtering language. It's basically, we started with it by looking at Prisma. They were the ones who started those filters in the JavaScript world. So Prisma is actually a JavaScript framework that does filters like that for node services. So we implemented that for .NET. So with just one line of code, you have all those power to filter here. And you could even say, okay, I want sorting in here. And then it's just another package. We combined the packages actually with the next version. But in this version, you can say, okay, I also want sorting. Restore that. And then you could say use sorting and add more to the pipeline. And you can extend the pipeline by yourself. So you could write more data aggregation pipelines here by just saying, and it basically works like standard ASP.NET Core middlewares, just on the field level. And you could say, like, I have next, I have the context here, and then you could do your aggregation code there. Okay. That gives you an idea how powerful you can do data aggregation, data filtering, and even more stuff. Okay, the second thing I said is challenging is scaling your graph. And we will look at two concepts tonight. One is persisted queries, and one is called GraphQL schema stitching. Let's start with the first one. So the problem with GraphQL sometimes is that queries could be very complex. And the first thing you notice when you write up a query is that it's actually a static query tree. But every time you send it to the server, you send actually unnecessary data to the server because you are sending always this large query. So it's a high bandwidth usage there for mobile applications, for instance. The second thing is that when you send in raw queries to the server, is that you give the consumer of the API unrestricted access to your query engine. And in the beginning of the talk, I said this is a superpower of GraphQL, and it is. But it is for your front-end developers. You don't want the other guys to use that maybe. Maybe yes, like if you are GitHub and you have a public API, they are using GraphQL as well in their version 4 API, then you want to expose it, but most developers don't want to expose their API to some other people, so they can restrict it. So the solution that Facebook has and what they are using is called persisted queries. And with persisted queries, we are not sending in the query, we are sending in the hash of the query. Or it could be any string, but they are using, for convenience, a hash of the string. And the server actually has the query pre-compiled and optimized on the server. So it's much faster as sending in a raw query. And you still have the power of requesting what you want during your development time. But now you have also the control that you have controllable requests during your operation times. Yeah, the second thing is that you not only have the bandwidth advantages with that, you also can restrict what is executed. Basically, whitelist all the queries that are allowed. Let's have a look at what that means. Okay. So we are going to 5 persisted queries. Okay, this is again a GraphQL Star Wars server here. I'm using that Star Wars example because the GraphQL community actually created a Star Wars example like the swappy.co for the REST APIs. So when you go after this talk and explore examples, you always will run across the Star Wars APIs. So it's quite good to use that. Okay, this is a standard GraphQL server built on ASP.NET Core. Has a lot more in there than the GraphQL servers I showed you before. So in order to support persisted queries, all we have to do is to add a persisted queries package here. And we implemented persisted queries not only for the file system, you can put in Redis there or Azure Blobs, it's just a different package. And also for the subscription stuff, we are supporting Redis as a backing system or other messaging systems. Okay, let's have a look how that works actually. So we go here in Startup. And what we have to do to add persisted queries is just one line of code again. We say add read-only file system query storage. And read-only because there are multiple flows to do persisted queries. We are using the simple one that just allows persisted queries now. And it should pull in the persisted queries from our query store that is located on our here in the file system. So basically I have a folder here, queries, and it has a query that is called foo. And the foo query is actually that. So basically it fetches the name of the hero from New Hope. Okay, and then the second thing I have to do is to add a middleware to the query level. So we have field middlewares that I showed you earlier, but we also have some kind of request query middlewares that are on top of the whole query request in the execution engine. I can change that by saying here builder, and I can tell my builder to use a persisted query pipeline. Basically, now my query engine accepts empty queries that just have a reference to a query. And they can basically then look up the query and give the correct query to the execution engine. Okay, let's start that up. And no, sorry. .NET run. Okay, now we are not using one of those fancy GraphQL APIs, because now we want to look at the raw request. So I'm opening up Postman here. Let's kick that. Don't save. Don't save. Okay, so I have a new request, and GraphQL requests are actually either GET requests or POST requests. POST requests are more common to use, but I will tell you in a minute also why you might consider also GET requests. So with a POST request, a normal GraphQL request would look like this. I would have here a JSON object that has a query, and the query could look basically is a standard GraphQL request here. Like I could say episode. Just let me fetch a different episode than we are using in our persisted query. Okay, we're using New Hope here, so I'm using Empire Strikes Back here. Empire Strikes Back here, and I'm fetching the name. So that is a standard GraphQL request that would go in, and you can imagine that. That is the name token. What did I do? Yes, I can see. Query. Hero. What the? I see. Sorry. Yes. So now the query is correct, the path is correct, and we get Luke Skywalker here. And you can imagine that like if you have bigger applications like the Facebook application, the queries are huge. So that's why it really saves you a lot of traffic when you are working with bigger examples. So we get our query here back. So with a persisted query, I would say ID, and then our persisted query is called foo. So I say execute the query foo, and then our execution engine executes that query. And this query is precompiled and does not need to do validation. Like my server doesn't need to pass that query. We don't have to validate that query because we know that it's correct because we are validating and compiling them when the server is starting up. And so why are GET requests then good? Like GET requests are good because we can actually specify those persisted queries in a simple GET request here. And this works very nice with output caches. Because now you can put that on a CDN, like fetch the data and cache that data on a CDN. So that's why it's also worth looking into GET requests sometimes. So let's conclude our first part of the talk. So GraphQL is a great way to expose APIs. They are more human readable, and if you design your model right, it's like an ubiquitous language. Like a lot of non-technical people could easily explore and do queries against the GraphQL backend because it's very easy to drill into the graph and explore that API. Data fetching and aggregation is done on the backend because on the backend we have unlimited bandwidth basically. Servers are close together, so aggregating on the backend is much faster than on the front end. the type system in GraphQL protects you from doing errors in your backend that might lead to errors in the front end. Like with the non-nullable example, for instance, the TypeScript developers can completely get rid of null checks for fields that are non-nullable, because the server is guaranteeing you that it will never deliver a null for a non-null field. That makes it much nicer to use than REST, because I don't have to check my responses. I know they are correct. But GraphQL also introduces new challenges like scaling your APIs, and we see another scaling example in the second part of the talk. And GraphQL is not always the best solution. There are better solutions for binary streams, and if you have just a simple health check endpoint, you don't want to do GraphQL because there's nothing to explore. You just do a simple REST request. So it's not always that GraphQL is the best, but as soon as you are having bigger data models, it's the better solution than REST. Okay, we start with something simple because it's what we do after the .NET client is really sometimes blows people's mind. And so let's start with something simple. So what do GraphQL clients actually look in .NET? Because with all those dynamic queries, how do they look like? At the moment, that's not our API. People querying GraphQL like that. We basically have a string, which is a query. And this is actually very horrible because login is not type safe. And this could blow up quite easily. So this is how users try to do it, like with the GitHub API at the moment. But basically all our strong types, all what I told you, is gone through the window with that. So we invented a new API. So we have hot chocolate in the back end, and strawberry shake is our new client API. Let's have a look how that works. So I have prepared a little project here. And this time we will consume the Star Wars API. So let's first start a Star Wars server, because otherwise that won't run very good. Run. Let's take our first example that we had, Star Wars, and okay. So while this server is coming up, let's have a look at the API. So this is a standard console API, because I'm not good at front ends, so you have to stick with console APIs with me. Let's get rid of this bad example that I just showed you. Client basically has some information here, like about the endpoint that we want to query. Like I told my API that there is a schema called Star Wars, and I want the schema to, I have the schema file that is the Star Wars GraphQL schema, and actually, if you would get started with it, we have a .NET tool. You could do something like this in it, and then tell it the server and stuff like that. And it would actually fetch down the schema. So you have a local schema copy here. And you have the information about the schema. And this is important because GraphQL can be compiled. And we actually hooked up into the compilation of .NET. And we are compiling all the GraphQL that you will write. So you will get actually IntelliSense and stuff like that while you write all your queries. And you just write GraphQL queries and retranslate it to C#. Okay, so let's do that. And the important aspect here, like I have Visual Studio Code, so I have to build to compile that stuff. With Visual Studio for Windows, we are doing the same like the protobuf guys. So actually, as you type, we generate. So let's start. We start with the queries. So we have a query document here. Let's call it queries. And then we could, let's start with something simple. We have the simple query here that queries the hero and episode, and we take New Hope. And we say its name. So there's another the thing that we have to do in order to let that compile here. We have to give our operation a name. And let's call it getHero. Okay, so like I said, with Visual Studio for Code, we compile that. And now we can see we have a generated folder here. And that's basically this translated into code. And now I have a character here. And the character only has the data that I actually used. So it's not the full character that I have in the server. It's just the character that I use here. And the client is already, because it's preview. And as I said, we are fully embracing the new features, so we have nullable reference types here. So because we know in the server this field could be null, it's nullable now in the client. Let's have a look at our actual Star Wars client. So the Star Wars client is now generated. I have here a getHero because I called my operation getHero. So I get a getHero function here, and I can fetch my data through that. So let's just type that here. Hi Star Wars client. And now I could easily fetch my hero here. And let's make that an async task. Yeah. Await that. And do that. Okay. Sorry, let's call that result. And now I could explore my result. And so I have a GraphQL result is actually specified. So a GraphQL result has a field data. Data actually contains my hero. So whatever I have as a result would be here. But GraphQL also has like error information. So I said we could have partial results. So all the errors about my results are here. And we made it very convenient so that you have, like with the HTTP request, you have something like called endure no errors, and then we would throw an exception like you would expect. But we give you the full power to get all the things out of the data of the actual GraphQL request like you would expect with any other platform. So that is nice. But actually, that's not useful because our query is kind of static. So in order to make that more dynamic, we would need to define variables. And GraphQL has variables specified. So you could, in your operation, define now the inputs that you have into your query. Like I could specify I have an episode here, a $episode, and it is an episode. Episode. Let's do that. Okay, let's compile that. And then we get an error. Because, why? Oh, actually, we don't have an error, I think. Yeah. Okay, that's one bug in my preview here. Needs to double compile. Okay. Actually, that works quite fine here. I get my episode. I can fetch for the episode. And now my function has changed. My Star Wars client here. Star Wars client. Has now the possibility here. And I can input here an optional of episode. An optional of episode, I explain that in a second, is actually implicit also an episode. So I can just put an episode in here and then could fetch my data. Why do we have an optional? Because in the server side, I can define that my inputs actually have defaults. So I could specify that this field actually has a default. So if this is null, it gets a default from the server. So that's why I need a concept that is called optionals. I can also define that in my query. I could say, in my query, I want the default to be New Hope. So I don't have to provide that, but so it's optional. But if it's not provided, then it will be filled in by the server. And we had to introduce this optional because null is not sufficient. We really need to know if it's not provided. But actually, it shouldn't bother anybody. Okay, so then there is this thing like in GraphQL, enums are actually always uppercase. So now we have an enum here, New Hope. And this looks like kind of crappy. Because it's not like we C# develops like our enums to be formatted with camel humps. So we could then introduce a new file. And that basically does schema stitching on the client side, because I can reshape my server schema into how I want it to be on the client side. I can say Star Wars extensions.GraphQL. And then I could say extend my enum and extend my enum episode. And I only want to extend New Hope. And I want it to be named, to have a name that is called actually New Hope. So I can rewrite the type names. I could also add new fields that only resolve on the client side. I could add fields that fetch from the client side data. So I can merge server and client queries and execute them at once. Okay, so let's rebuild that. Yeah, let's see. Yeah. Now it's a compilation with actually is right. I have here New Hope and now has my camel humps. So this is quite nice because I can shape really my types how I want them on the client side to be. Okay, let's make it more complex. Let's say we have friends. And the friends have nodes, I think. Nodes, and they have name. And then compile that. And we will get quite crappy code because it should be right. Unsigned, okay, that's okay. So now I get something like a character 1 and a character, and that looks kind of crappy because I have a character 1 that has a friends, and I have a character that has friends, and I have character 1 that has just a name. But there's something called fragments in GraphQL. And fragments define reusable components. So actually, I wouldn't write those GraphQL queries like this. And if you look at the Facebook API, they don't use that like that. So they would specify maybe a fragment here. And that's why I say you can start thinking about it as an empty JSON graph. But when you're drilling into GraphQL, it is a super powerful syntax. So we can specify a fragment here. And we can say, OK, I have a has name maybe. And this goes on the character. So basically, I'm describing now a component here that only has a name on top of this character type. And now instead of using name here, I'm using has name here. And then I could further go on, take that again, and say maybe I have a has friends. And this has friends maybe gets this construct, but then reuses this again. Oh. And actually that is very aligned to how we do things in C#. Because now our compiler can use that. Can use that to infer from that interfaces. So now I have an interface I has name and I has friends. And if I look at the character actually implements I has name and has friends. And now the API is really nice to use in .NET because it has quite good names. And I can type checks on them and stuff like that. And sometimes a character implements this or that. Okay, let's just copy in a bit of setup code here, because we can run that actually. And that's also kind of nice, because we generate you all the setup code for your dependency injection. So in the end, this is all generated. And in your C# Xamarin, or even it works even on watchOS. So if you have an Apple Watch, this client also runs there. So, but if you're using it with dependency injection, we can also generate it without dependency injection, and then you get a builder pattern. Then you can have a client builder that you use, for instance, on watchOS to set up your client. You can also use any other dependency injection. But if we generate it with Microsoft, you basically say, okay, I have my service collection. Then I add an HTTP client, and that's the connection to our server. You name this the HTTP client like you named the client. I called the client Star Wars client, so it is Star Wars client. Then you tell the HTTP factory where the URI is. Maybe you add some poly and stuff like that. And then it's one line of code to set up your server. It's just add Star Wars client. We generated you all here. Okay, and just let's paste that in. And then we have, in this example, if you use it in ASP.NET Core, you don't have to do that. But in our example, we use the service collection, we build a service provider from it, then we get our Star Wars client, and we fetch a hero here from New Hope. We ensure that it has no errors, and then we just print the name here. But if we want to explore the API further, we can see it's now very nicely to explore. We have our friends, which is on a character connection. There's no character 1 anymore. We have our nodes here. We could fetch the first node, put some link. And then we can see it has a name. And it has name in this case. So it's very nice how we can infer from the query that you write, the API that you want to use in .NET. So let's run that. Okay, we get R2D2 because I just printed the name out. You could print it also other stuff out. The important thing here is we are fully compatible to the non-nullable pattern. That means the graphs basically are immutable in this case. And if you look at it, it's quite nice formatted. So there is no, we put a special emphasis on not generating crappy code. Like a lot of generators have a lot of crappy code. So it's kind of nice to use, and it's easily to use. And it really compiles. If I would mess this up, say .NET build, I get a correct error here in my GraphQL file. I can jump in here. That's an actual compiler error. In Visual Studio for Windows, you get it in your grid down there. It's just with Visual Studio Code, you have a lot less tooling. So, but I still can jump in here on my link. I get to the actual error here, and it says the specified fragment does not exist. Or if I did another mistake here, let's do this. I would get another compiler error that this query is wrong. And the cool thing is that if you compile, the field does not exist. And the cool thing is that you can combine that with tooling in your DevOps pipeline, for instance, where you fetch the schema. We have a .NET Update schema, and then it doesn't compile if the server changed in a way that your client would not be compatible anymore. That's real power here. Okay, so that's how you can do clients with GraphQL and Strawberry Shake. We are at the moment in preview. It also works with real time with the next preview that we are releasing. Actually, we could generate already real-time code here, but it would crash. Like it would generate, actually, I could do a subscription here. It would generate, but it wouldn't run. Okay. Okay, let's talk about microservices. And that's very interesting with GraphQL. Because GraphQL is built for microservice, but if you think about it, like all what I told you so far is kind of monolithic. Like we have this one endpoint, we have one data graph. It sounds like a monolith. So how can we do microservices with a monolith? Let's first line out some principles. Because what we want is one graph. We want one data graph to explore. And it's worth to not think only about applications. Like you could think, let's build one data graph for my company with all the data in there. I think even the Microsoft graph is much better with GraphQL. And we want one endpoint to consume our data. So one endpoint to fetch. We want it simple. And we want to be able to fetch everything with one request. But we want to basically be able to implement it in a federated way. We want to have microservices that offer the data like it's efficient for those microservices, not efficient for the data graph. The solution to that is called schema stitching. And this term is kind of made up. Like there is a company called Apollo, and they are the leading company in GraphQL. They are doing the Node platform, and in the Java ecosystem, it's much bigger than with us .NET developers. And they turned the coin schema stitching, but they deprecated their schema stitching and renamed it to federation. So if you're looking for schema stitching and you see something like it's deprecated, they just renamed it. It's just a name, it's not a specification. So we still call it schema stitching because I kind of like the term. So what is schema stitching? Schema stitching, if you just take what Apollo does, is just the capability of merging different schemas into one schema. But with Hot Chocolate, it's more, and our ambitions are bigger for that. So let's have a look at a typical setup. So a typical schema stitching setup would consist of multiple servers. Like we could have an Apollo GraphQL server, because GraphQL is spec'd. It's a standard. So schema stitching works with any GraphQL server. So if you have like multiple Scrum teams and each team has its own technology stack, then you could mix and match the GraphQL servers. Maybe there's a team with Go or a team with Apollo, basically Node, and maybe there's a .NET team. So basically we could have an Apollo GraphQL server. And maybe in our example here, our GraphQL server has the user data. This is our user service, knows the users. And maybe we have a .NET team, another GraphQL server, and maybe it has all the message data from our Twitter API. And maybe somewhere in a cupboard, there's this old REST endpoint, and we don't want to rewrite it. So Hot Chocolate can stitch also this into GraphQL GraphQL. So you can provide us your REST API, and we make it GraphQL. And then we have something that's called a gateway. And the gateway is another GraphQL server that has some extra middlewares that explain to the schema how to rewrite queries from monoliths into those microservices. But it's very abstract to explain that in slides, and it's much nicer to see how that actually works. So let's see schema stitching. Okay. Okay, we have multiple servers here. Like we have this is an example that I gave to Swiss Life. It's an insurance company that sells insurances and buys real estate. And so basically they sell you the life insurance and they put the money in real estate. And so we have a contract schema here and we have a customer schema. Let's fire them up and explore them. .NET run contract schema management project. Okay, while this is coming up, 7 stitching. Which one did we start? Contract. Ah, super. Customer schema. So we have two schemas here. One is the customer schema that is coming up now. It's on port 50. Let's explore that. That basically holds all the customer data. So if we look at the schema, we have a customer here, and the customer maybe has a consultant, basically the person that sells you all the insurances that you don't need. And we basically have address data here. So we could explore that. We could fetch all the customers here. We could fetch the names of the customer. Maybe we could also fetch the consultant that sells us all this crap. So there. Maybe fetch the IDs. Let's have a look. We get all the data here like we asked for it. We have like a Freddie Freeman, and he has a consultant, John Belfieur, and yeah, a customer like that. And we have an ID here for a customer. Let's copy and paste that and keep that in memory that we pasted this here. So then we have a second endpoint that has all the contracts data. 51. It's on 51. And this has things like life insurance contract. It has queries for contracts. So let's explore what we can do. We can ask for contracts, and we have to pass in a customer ID here. Okay, let's pass it in. And oh, I just have an ID here. So I can query for that. Okay, that's not much. But there is a concept in GraphQL that is called interfaces or union types. And in this case, I have an interface. So I have life insurance contracts and I have maybe other contracts. So I can ask for data. Okay, if this entity is actually a life insurance contract, then give me the premium. So basically the money I have to pay each month. But if this is actually some other contract, maybe give me the expiry date. So I can see I have very specific data in a very specific way for the microservices to fetch here. So what the client, the front-end developer want is one endpoint, one way to query this data. Okay, so let's set up a little gateway. Okay, a gateway is a standard GraphQL server. The only difference here is that we have a stitching package. And okay. And what we also have here is we declared the HTTP factory, and we basically pointed to the endpoints that we want to stitch in. Like we have endpoint 50, the customer endpoint, and we have the contracts endpoint. And we made it named clients. And this is very good because you can now use Poly to make it very resilient. If maybe a request goes wrong, then you refetch and stuff like that. Okay. The second thing now is we're using our special extension method here that's called add_stitched_schema. And this stitched schema has a builder. And with this builder, I can very easily, just reformat that, describe how I want to stitch my schema together. So I could say builder.add schema from HTTP. Actually, I wouldn't fetch the schema on a production system. I wouldn't fetch it via HTTP, the schema. I would actually do the merge already in the CI pipeline, because then I don't deploy schemas that would break. But it's always good to have that for demo purposes, because I can just say, okay, fetch the schema from there, and then we'll do it from here. Okay. So now I just have to provide my schemas here. And basically, the first request of my front-end developers is now fulfilled. I could fire that up. And the need to query everything in one go is now fulfilled. Do we have a third? Yeah. Okay, because I can't fetch that. And now, oh, did I fetch? Did it fetch? No, it didn't. Just let me see why not. Error. Ah, what did I do wrong? Let's compile it. Others? Yeah. What? Wait. Let's stop that. Donut build. Ah, now it builds. Watch run.
You said something else is already running on 5,000.
Ah, yes. Thank you. Yeah, actually. Okay, let's put it on a different port. Let me just grab that code from here. Let's kill that one. Code. Let's put it in 5001 and then. No, it was here program. Just let me grab this. And then let's put it here and here. And put it on this port. Okay. Let's get this one again running. No. Sorry. Okay. What? Which one did I kill here? 5001. Okay, that must be the contracts .NET run. I hope. Okay. Now is everything up again? And now we should be able to do that. No. Address is still already in use. Very strange. That's wait, I have to reset. Code. be. That can't be. Okay, let's give it a completely different one. Yeah, okay. Yeah, my other examples might have blocked the port. Okay, let's refetch that. And now we fetch this endpoint. It's just 2 lines of code I said to the schema, take this schema and take that schema and merge it together. And now what I could do is I could grab this query, paste it in here, and it would run. Okay, that's an easy feat. But I also could take this schema, put it in here, fetch that, and it also runs. But my front-end developers would tell me that's actually crap. Because now I have one endpoint, but I still have to paste IDs and stuff like that. Okay, this conversation actually happened when we talked to our front-end devs. What they actually want to have, they came up with something like, okay, we want to explore our data like this. We want to have a me endpoint, me field here. And I want to ask maybe from me as the signed-in customer of this application, and I can explore everything from the customer, from the signed-in customer through the me endpoint here, and then I want to have maybe the contracts here, and I want to explore the contracts through the me endpoint, and do this. So we went back and we then introduced something that is rewriting the types. And this can easily be done. Like we have here add schema and our add schema endpoints, but we can now say .add extensions from file in this case. I can say grab this extensions.graphql file. And then we can use GraphQL to rewrite our types. Like I showed you in the earlier example, in the client, we basically put under the client compiler, we have the stitching engine. Okay, so what we can do now is we could tell our engine to extend our type query. And our query type should have a me field, and the me field should actually be the customer. But then we also have to tell our engine how to fetch that. And that is done through something, these guys here are called directives. And they have the power to change the execution flow. So basically directives are actually associated with middlewares. So what I can do now is to say here delegate this call to a schema called customer. And then I have something called a delegation path. I don't have to specify that every time, but in our case, I do want to fetch the customer. But I don't want to fetch any customer. I want to fetch a customer that is logged in. So I can specify here a special variable that is called context data. So I want to fetch something from my server context, and I could call it the user ID. Let me reformat that. Okay. So now the schema already would fulfill that, but it would run into an error because we have to provide that context. And we have something called a request interceptor. So basically we can intercept each call that is coming in, each GraphQL call that is coming in, and we can intercept here the HTTP context and the GraphQL request builder, so actually the builder that builds the request for the execution engine. And then So actually, when I would do that in production, I would grab maybe my user would be signed in, and I would have some claims. Maybe I would do call to my database, look up some special data here. In our case, we will just add a fixed ID. So we say our builder here that we want a property, a special property. I think I called it user ID. And I don't have the ID in my head anymore, so let's grab some here. So let's imagine we actually fetch that from our context, right? We could fetch our identity of the principal from the context and do stuff with that. But we are just putting it in fixed. Okay, now my GraphQL server actually knows that we have a user ID here. It's this user ID, that's my logged in user, and it would delegate the call here. Okay, so let's crash that. Do watch run. Okay, it's up, and let's explore the API. Because now I get a new field in my query that is called me. It's a customer. And now I can do the first part here. Like I could fetch my me, and it's Carol Danvers in this instance. And I could do everything that I could do on the microservice, like fetching the consultant, and it would get this consultant. So then I can go on and rewrite my API as I want. So I could invent, like, let's extend the type let's extend my customer type from the other server, from the customer schema. So I can extend my customer. Okay. Okay, sorry. So I can extend my customer like I would do here, and then I will get my customer field. Maybe I have this to copy paste here. It's a lot of. I have a copy. So let's paste that in, and then you at least get the result. So we can put that in, and then we actually get what the client users want. But there's one more thing. Maybe I also want to rename types, because life insurance contract sounds kind of bad. We just want to get rid of the contract. So let's do that as well. Just by rename type. So we can say this type is actually now this type. And last but not least, let's kick out all of the microservices that we don't want. So we get rid of the root type. So we actually flush out everything that we don't want. And now we can remove that extend here. And we define now the type locally. And we will end up just with the me field. Okay, sorry. So let's recompile that. Let's have a look at our query type. Where is it? Query. And now you can see we have just the me field here. Everything else is already invalidated. And now we can also grab here our contracts data. And I don't have to specify any ID. And I can say if it's actually a life insurance. So the point here is I can completely rewrite my source schemas. And if we had more time, I could show you how to integrate OData and the rest. So you can fetch this data very efficiently. You can completely rewrite your domain services. And that means you don't have to compromise your domain service design. You can design the structures as you need them there and then rewrite them with just a very thin gateway layer. Because if you look at the code, we didn't write all the resolvers. It's all generated for us. We just specified kind of, with the schema definition language of GraphQL, we specified how our schema should change. And then we have like here a couple of lines of code, and that's what was it. So it's very easy to rewrite schemas. So as a conclusion here, it's easy and with minimal amount of code that you can create a gateway and get what you actually want. And you can describe GraphQL with GraphQL. I can use just the GraphQL schema definition language to define how my types should change. You can merge multiple data sources together, and if we had more time, I could even show you how to stitch in SQL services and other stuff. So you can, in the gateway, just merge things together. But it adds complexity. Like you have to think about things like poly, like making it resilient to fetch data. And so I would say start with a single server and then explore if there is a need for that. So sometimes it's easy to start with a simple GraphQL server before stitching. So we are an open source project. We are the fastest GraphQL server on the .NET platform, twice as fast as the as our competitor. And we use only a fraction of the memory for each request. So it's only a third of the memory. And actually, that with the next version, we are halving that performance statistics. So we are then 4 times faster than GraphQL.NET. So everything you saw is open source. It's free. There's no hidden charges. Everything is under the MIT license. You could even copy it and do your own thing. At the moment, we have the GraphQL gateway and the server, and they are production ready. What I showed you today also was the GraphQL client that we are hoping to deliver in January, and also the tooling that you saw, the UI with all the IntelliSense and stuff. It's also done by us and should arrive with the next platform release in January. But we are not stopping there. And for August, we are also building parts of this already. We are introducing automatic database mapping. That means we don't only understand queryable, we also you can just throw us a database there and we translate it completely into GraphQL. Or you write a schema and we translate it, we build up the database for that schema. Also, we are the first GraphQL implementation that actually will introduce execution plans, which basically make all those data loader stuff that I showed you obsolete, because we can infer data loaders from your data structures. We can automatically optimize your data from your queries, and that makes it very powerful. So all of this is also free and open source. So you can track what we are doing online, and everything is on GitHub. I already pushed the demos. I will just do another update in a minute, and then you have all the demos, all what we done today in this repo. You can download it and look at what we actually did today. Yeah, that's it basically.